Hi, today I'm gonna show you how to create some interesting shapes like this with golden ratio spiral and the thought of iteration and fractals. So first of all, this is one of the shape I got here, and as you can see it has some patterns with it, and I'm gonna teach you how to make it. So first of all, I'm gonna introduce how the fractal and the iteration works. So as you can see here, some kind of interesting pattern is repeating itself and creating a shape called fractal. And what we are gonna do is not as complicated as this one. So this is actually the formula I can found from Wikipedia and then translate it to Houdini language. So today we are going to do some like easier version. So this is another shape I got here, and so I'm gonna explain the code a little bit, and you can just copy the code if you don't really want to understand it. But actually, it's not too many things to understand. It's just translating the Wikipedia into Houdini language. So I set up a few parameters here, and then I set up a parameter uh, called 2 divided by pi, so I can use it later, and then a few more parameters. So position means the position of the points, and then the radius is controlling how the spiral is growing. So let me revert all these to defaults. Angles. Oh, sorry. Defaults height 0. So for each iteration, the program is gonna run this code once, and then until it reaches the endpoints, which is the number of points we set, and it stops. So we set it to 20 points, so it will iterate for 20 times. So the current angle is, so we created this spiral with angles, and you can also do it other ways. This is just one of the way to do it. And so step angle means each point it will create, it will add the step angle to the last point it has. So it times float I means how many iteration it is for the point in the whole spiral. And radius is calculated by this, is actually calculating the distance between the point and the center, if I am understanding it correctly. And then these three are just the actual position for each point, so we can like output the point to the screen and then add points. So the sweep angle, we can, if we change the angle, it gets bigger and bigger, and you can see more clearly if I increase the number of points. Okay, and we can change the growth factor to whatever we want to create like different shapes. So one interesting thing I noticed is that if we increase the sweep angle, it's creating an interesting pattern. And the next step, so we created attribute wrangle to input these uh, codes. And next step, if we do this point wrangle, so it's actually rotating the orientation for each of the point. So if we You can see the direction of the points. Okay, it's not hard to see here, but it's actually changing the orientation of the point. So if I use copy to points, let's say I copied whatever a box to the point, and you can actually see how it changes the direction. Let me show you right here. So this is actually an object I modeled in Maya, very simple object, and here. So you can see they are not facing the same direction. But if I bypass this, they are all facing the same direction. So after this, same thing again. So I copy this and paste it here, and copy the points again. So it goes like this. So I bypassed this node to have better results. Well, you can change the value, change the nodes as you like, or iterate it more times, but it just take longer for the CPU to calculate the result. So this one is the same code, but I just change a little bit of the value. So you can be creative and create your own pattern. And I kept this because I want their angle, their orientation change. Otherwise, it will become very boring. So, and then this is one of the shape I got. This is not exactly the shape before, but you can be creative, like change the value as you want. The growth factor here, this is the default value I set to it, and this is actually the golden ratio. So it creates the spiral we see here. If we change the value, it's not the golden ratio spiral again. Not the golden ratio spiral anymore. Alright. Let's go back to, let's check other things I got. Looks like this. This one looks like this. They're kind of similar because they are all following the same formula. So they all grows in the same golden ratio pattern. So one interesting thing is if you change the value, you can actually get kind of cool animation here, and you can render it out. It will take very long time for the computer to calculate if you don't have a very powerful CPU. Okay, and I can explain a little more about a fractal. So the fractal is basically a 3D. This is the 3D fractal. It's basically the iteration of points. So I started with a volume. This is a box of a lot of points, and then I use some formula to iterate. As you can see, it looks very similar to the formula before I show you. So it iterates on the given iterations, and then some calculation here, and it gets this result. If I change the formula, it looks differently. This one will take longer. So I'm actually using a controller to control the different formula I'm using. So these four are actually different code, different formula. And if I go to the final result and I change the controller here, so the iteration here, the higher iteration gives more detail, but it takes longer to calculate, and n is I'm not completely sure how it works, but it is also changing the detail and the shape of the fractal. And resolution, obviously higher resolution you get like better details, because if you zoom in infinitely of a fractal shape, you can always see the same shape happening again and again. So higher resolution gives you more detail, and you can like get closer and see more like the shape happening over and over again. And here formula, I can switch between different formula here, like four different formulas. It will take a while for the CPU to calculate. So this formula are actually like created very carefully by like with math, so it's very hard for me to change the value and get a very good control of the shape. I did try to change a little bit. So as you can see here, these two formula are quite similar, but I just add a little bit here, and then the result becomes completely different and almost uncontrollable and not very satisfying. So yeah, it looks like this. Anyway, back to the geo here. So if I want to render it out, I can keyframe the sweep angle here. So as you can see, I got 2 frame already keyed, and then if we want to do it, first jump to frame 1 and press Alt and left click on the parameter you want to key. Let's say growth factor, and it becomes green. And then to the frame you want to end and left click, Alt and left click again, and then it becomes green. And you can also see the frame becomes green. It is meaning the frame is already being keyed. And then go to output and create a mantra. So this one gives you a series of pictures. If you want FBX output, you can use this one, Finbox, and then set the frame range and the output like directory. And also here is pretty similar. Yeah, like this. Okay, export it as EXR, and you can use Adobe Premiere to make these series of pictures into a actual like short video. Okay, that's pretty much it.